All right, thanks, Ingrid. Yeah, so we're gonna talk about sampling and testing today for asphalt pavements, and really what we all want is a quality asphalt project. Quality starts with the plans and specifications for a project. You know, the plans that provides layout, dimensions, how we're going to build the job. Specifications describe project specific requirements for materials and workmanship. They have general and special provisions, and the sampling and the testing. When we talk about quality, there's 6 core elements of a quality assurance program. The 2 keys are quality control, which is the responsibility of the contractor, and acceptance, which is the responsibility of the agency. The other 4 include independent assurance, dispute resolution, laboratory qualification, and personnel qualification. These are all very important aspects of a quality asphalt project. Presentation outline for today, we're going to spend some time talking about variability. Then we'll talk about sampling methods, testing methods, and a little bit on identifying issues at the end. As we go along, if you have questions, just ask those to Ingrid and she'll interrupt me and we can go over those questions as we're going. We'll also have time for questions at the end. It's important to understand that the total variability of a particular material is the sum of several definable variables. These are sampling, testing, production, and actual material variability. What is important is actual material variability. Variation of construction materials is inevitable and unavoidable. If you can assign variability to a specific cause, such as segregation of the mix or a problem with a cold feed belt, it should be fixed and eliminated. Everything varies. In asphalt construction, the sources of variability are listed on this slide: sampling, testing, materials, and construction. The goal is to reduce the variability resulting from sampling and testing so that the test results are related to the process of being sampled and tested. In construction, we want to minimize variability. Variability in your test results is a combination of the variability caused by sampling, the test procedure, and the materials and construction processes used. The goal is to have the only source of variability to be that associated with the materials and construction processes. So if we can reduce or eliminate the variability in sampling and testing, then we just start testing for that variability in materials and construction. Sampling variability is caused by the random variation in the sampling methods and procedures. Even when everything is done right, there'll be some variation caused by the sampling process. Testing variability is caused by the random variation in the testing methods and procedures. Again, even when everything is done right, there will be some variation caused by the testing process. Therefore, it's very important that the sampling and testing personnel be properly trained, and it is emphasized to them that they must follow the established procedures. There is some natural variation in the variability in materials and construction, but it can be controlled using consistent construction practices and procedures. The key to understanding variability is the use of statistical analysis procedures along with statistical random sampling procedures. Statistics is a science that deals with the treatment and analysis of numerical data, where random sampling is a sampling procedure where any specimen in the population has an equal chance of being sampled. Now, I won't go through a whole class on statistics and all that we could be here for 3 or 4 hours talking about that, but just wanted to give you a little bit of guidance on that. A population consists of all possible observations of a particular material. For example, this large cube-shaped object can be thought of as 100 tons of hot mix asphalt. The 100 tons consists of smaller cube-shaped blocks which represent potential specimens. Assume that the cube represents a lot of hot mix asphalt and that we wish to know the density of the hot mix in the lot. Obviously, to determine the best estimate of the density, every bit of material in the lot must be tested. This would be complete enumeration. Since that is not feasible, sampling is the practical solution. A sample can be selected from the lot of material, and data from the sample can be used to estimate the density of the hot mix in the lot in order to make a decision regarding its acceptability. The relationship between the properties of the sample and the properties of the population is an important aspect of statistical theory and practice, since good estimates of the properties of a population require valid samples. Two concepts that are of particular importance for ensuring sample validity are random sampling and controlled conditions. Another concept of importance to the analysis of construction data is the concept of precision and accuracy. It is desired to have both precision and accuracy in your test results. The concepts of precision and accuracy are fundamental to the understanding of variability. Precision refers to the variability of repeat measurements under carefully controlled conditions, where accuracy is the conformity of results to the true value, absence of bias. Bias is a tendency of an estimate to deviate in one direction from the true value. The analogy of a target is a practical way of understanding the relationship between precision and accuracy. A practical difficulty in measuring accuracy is that the true value must be determined. Ideally, the true value should be determined or measured by a method of high precision with as little bias as possible. In this example of this target here, there's good precision. You can see the black dots are grouped together, but poor accuracy. So it's off from the target. So that gives us a biased result. In this example, there's a little poorer precision, but good accuracy. The black dots are grouped around the center, but they're spread out a little more. So when we talk about reducing variability, we want to reduce it in all three aspects: sampling, testing, and material construction. Sampling variability typically accounts for 10 to 30% of the total variability. Sampling variability can be caused by sample locations, sample methods, sample size, or sample splits. Test method variability typically accounts for 30 to 50% of the total variability. When we're talking about test method variability, there are precision and bias statements. So when we're following test methods, there's certain precision and bias statements that go along with those test methods. There's also variability within and between lab. So if we're testing within the same lab, there can be variability. And typically when we test between different labs, the variability is increased even more. It's important to know the details of the test method and the options within the test method. When we talk about test methods, typically you have ASTM and AASHTO test methods when we're talking about acceptance of asphalt materials. Here in Michigan, we also have Michigan test methods, or MTMs. Typically, when a state has their own specific test methods, they're looking at those ASTM and AASHTO test methods and then selecting certain options within those test methods so that they become more consistent. So when we talk about precision and bias statements, there are within and between lab precisions, and there are different examples of how those can be quantified. There are national examples, state round-robin testing, or local, county, regional round-robin testings, things like that. And by doing these round-robin testings, you can kind of quantify that precision and how much variability there might be between test results, either within or between different labs. So how do we reduce sampling and testing variability? It's done through technician training, certification. We want to make sure we have the right people out there that know what they're doing when you're taking samples, and also doing testing. We want to have laboratory accreditation. We want to make sure that all the equipment used in our lab to do testing is certified and calibrated so that it's working properly. We talked about regionalized standardizing test methods and the test method options here in Michigan. We do that through the use of the MTMs. And then proficiency sample programs by running these round robin testings where labs are testing the same material. We can get a better idea on the consistency of the testing. When we talk about material and construction variability, this typically accounts for 30 to 40% of the total variability. And there we're talking about the asphalt binders, the aggregates, things that go into making the asphalt. We have variability in the production and also within the placement. So following good practices can reduce that variability in those aspects. So when we talk about the total variability, we talked about if we can fix the sampling and the testing variability, what we're really testing for is what the materials and construction variability is, and that's what our payment should be reflected on. As we reduce variability, overall quality can go up, and we can get a better idea that what we're testing is what we're actually getting. Because again, remember, we're testing little parts of the whole. We can't test every ounce of mix that we're putting out there. So on this slide here, the red graph on the bottom, it's your standard curve. As those variabilities are increased in the sampling and the test method and the materials and construction, it flattens out that bell-shaped curve. So there's a higher probability that more of that material could be outside of the acceptable limits. Whereas the blue, as we tighten up those variabilities in the sampling and test methods and materials and construction, we get a tighter grouping around our quality goals. So next, we'll talk a little bit about the sampling methods. And I'm going to focus mostly on the local agency spec here in Michigan. It's 20 SP 501I. And when we talk about sampling asphalt there, so when does the asphalt need to be sampled? Anytime production paving is greater than 500 tons. So that's mainline out on the road, and that's per mixture. If it's under 500 tons, visual inspection is acceptable, and it's also acceptable for non-production paving like driveways and approaches and hand patching areas and things like that, kind of non-typical paving. So for production paving over the 500 tons, the goal is to collect a representative sample of the day's paving operation. So a representative sample is defined as 2 samples per day per mix. So if we're paving base mix, we got to get 2 samples per day on that, or leveling or top, 2 samples of each different mix type. There's also a minimum of 3 samples per day per mix. So say we had a project where we've got a small tonnage project, it's probably less than 1,000 or 2,000 tons, and it's probably going to be all paved within one day. We have to get a minimum of 3 samples of that mix. What size sample should be collected? A 2,000 gram minimum, which is approximately 43 to 45 pounds. And can the contractor pull the sample for the inspector? Typically only if the following 2 conditions are met. The inspector witnesses the sample being pulled, and then the inspector takes immediate possession of that sample. So that's an option if the inspector out there isn't qualified to take the sample or doesn't want to take the sample, then you can ask the contractor to take the sample for you. Asphalt binder sampling. So aside from the mix, sometimes we've got to pull binder samples. And those are on projects which require asphalt binder sampling. The engineer can also require witness sampling to do that. Anytime we're sampling, we got to make sure that we're doing it safely. You got a question, Ingrid?
I have a question myself.
Oh,
How much binder do you need when you're doing that testing?
what binder sampling?
Yeah,
There,
how much of the
there's
binder?
yeah, there's specifications. Typically, you've got to take like a 3-gallon sample and a quart sample,
Okay,
and then it's specified where you have to take it and all that based
gotcha.
on specifications for the particular job.
Perfect. Just a reminder, folks, if you do have questions, we've been quiet today. So if you do have questions, please put them in the chat or you can put them in the Q&A.
So far, it's been a lot of general information on variability, so maybe there'll be more questions later. So I was talking about sampling safety. You always want to be safe when you are sampling. If you're taking samples at the plant area, you want to always stop at the plant office before entering a yard to sample. Let them know that you're there. There's a lot of things going on in an asphalt yard. You want to always confirm the safety policies of the producer where you are sampling. Um, Make sure that you're wearing your personal protection equipment. Um, while you're at the plant, stand clear from trucks and loaders. They're moving around. Use caution near conveyors and watch for falling material. You got to protect yourself. The hot mix is hot, and seek any medical attention or advice if you're burned or injured. So, what kind of sampling methods do we typically use on local agency projects here in Michigan? Again, the Special Provision 501I allows the use of MTM 313, which I explained earlier. MTM is a Michigan test method, or MTM 324 for acceptance on local agency projects. MTM 313 is kind of a catch-all for different acceptable ways to sample asphalt here in Michigan. MTM 324 is specific to if you're sampling mix from behind the paver. So most preferred methods from MTM 313, as I said, it covers a lot of different methods, but the most preferred methods are mini stockpile and sampling from the haul unit. So sampling from a mini stockpile, how that is done is the contractor will dump out a mini stockpile from the trucks, approximately 3 to 5 tons. And then to get your composite sample, you take at least 4 equal increments of material from around that stockpile at different heights. So at each location around there, you have to dig into the pile about a foot, forming a vertical face to remove any segregated material. And then you shovel, bringing the shovel up the entire vertical face to obtain the sample. So all 4 of those scoops are combined into the bucket to form one composite sample. So you can see from the language here that it's very specific on how that you do this. The biggest thing you don't want to have happen is you don't want to get the mix segregated when you're taking the sample. So we've talked a little bit about mixed designs and things like that in the past, and segregation can really mess up your test results. And that's why these sampling methods are very explicit, and people need to be trained on how to do this stuff because it can mess up your test results, which induces more variability, like we were talking about. The other way is sampling from the truck transports. And there you want to, by a random method, select the unit to be sampled from the production. That's also included in the taking it from a mini stockpile. You have to have a random method of choosing, one of the trucks in the morning to take the mix from. Same thing here. If you are taking it out of the truck, you want to, in the truck, you want to get at least 3 approximately equal increments, and put those into the bucket as well. So you can use a scoop or a shovel when you're sampling from the truck transports. MTM 324, if you are sampling behind the paver. So this is the mix has gone through the paver. It's loose out on the road. And there's quite a bit to MTM 324, but typically you're putting down plates and there's specifications on where the plates can go. You want 3 of them across the mat, and then you're taking 3 scoops out of there to get your composite sample. Really, the ultimate goals of sampling is, like I said, you want to obtain a representative sample, and you want to have a standardized approach to reduce the variability. Like we talked about, you don't want to get that mix segregated. If you lose just a few big stones out of the mix when you're scooping it, or not properly preparing it before you scoop it, that can cause a lot of erroneous test results. Any questions on sampling methods before we get into testing methods? Okay. So when we're talking about testing methods, we talk about the asphalt testing labs. Labs permitted to test HMA must be qualified in one of 2 ways, either through the MDOT HMA QA manual on state projects, or accreditation through the AASHTO AMR-L program. And you need that accreditation if you're testing on federal projects. So any projects that have federal money in them, which some local agency projects have here in Michigan. Contractor labs can be used to test HMA for acceptance if the project is on a non-NHS route. This will most likely be indicated on in the contract documents.
Yeah, we got a question. Is a random number generator required to select which truck to sample? Like, how random do we have to be?
Yeah, typically on an MDOT job, yeah, there's a random number sheet that's prepared and all that ahead of time. Typically on a local agency job, it's a good practice to use a random number generator so that you are getting that random sample. I don't think it's required by the specification in there to have a random number sheet made up like it would be on an MDOT project.
All right.
Usually those random number sheets that have to be generated have to be signed off on at the pre-production meeting and all that. So
Gotcha.
everybody knows it wasn't switched or anything like that. It's
Okay.
truly random.
Truly random. Okay.
But the local agency specification says, to take 1 sample in the morning, 1 in the afternoon, or if it is just 1 day's production, then you got to split it up into 3 samples.
Okay.
So yeah, you should generate a random number. And okay, if I'm planning on paving 200 tons in the morning, somewhere with that random number times my 200 tons, I get that. It's at ton 110, then I got to figure out what truck that's coming in, and I'm going to take my sample out of that truck.
All right.
Yeah. Good question. So when we talk about asphalt density testing, the 501 local agency spec allows for 2 different methods for HMA in place density: a nuclear gauge density reading, or roller method with a density gauge. Requirements are 92 to 98% of target density. Target density is figured through the GMM found on the JMF for that particular mix. So that's how you do it on the local agency side. You get into the MDOT specification on MDOT roads. You've got coring is the way to select to measure density. And that's a whole nother subject we could spend an hour on. So when we are doing our testing in the laboratory, we want to make sure that we're also being safe there. Again, the hot mix asphalt temperature typically is around 300 degrees, or could be even higher. Always use personal protection equipment: long sleeves, heat gloves and mitts, safety glasses. If you are using the ignition furnace to test your asphalt content, those exceed 1,000 degrees. So you want to make sure you have a face shield along with long sleeves and high rated heat gloves if you're using that method. Also in the laboratory, if you're using the vacuum extraction tests to check for asphalt content, that requires the use of a solvent to dissolve the liquid asphalt cement in the mix. So you want to, PPE can include the neoprene and rubber gloves to avoid skin contact. You don't want to touch these solvents. You want to have adequate ventilation, safety glasses. Always keep solvents away from open flames, obviously. And it's also important to not dispose of solvents in wash sinks, only dispose of them in approved locations specified in that laboratory.
We got a question. Are non-nuclear gauges, non-nuclear gauge use, is that allowed in Michigan?
Yes. Yep. Yep. We can use those. So next, we'll talk a little bit more about the mixed testing procedures. And really all these tests for acceptance can be found in the MDOT HMA production manual. Procedures include sample reduction, GMB, the bulk specific gravity, TMD, the theoretical maximum density, or the RICE or the GMM, vacuum extraction, and ignition furnace. Those are used for determination of the asphalt content. And then you can do a gradation off of that sample after that's done. So we talk about HMA sample reduction. The entire field sample must be used to quarter out test samples. There's different examples in the production manual of how to properly quarter those samples. So it's important that you properly quarter your samples before you're running tests on them. Again, it's to kind of make sure that you've got a good composite sample. We're dumping that bucket out, and that's got scoops from 3 or 4 different places. And then we want to quarter it so that we're making sure we get a good representative sample of that sample. You'll never quarter or split out or prepare a sample in the field for lab testing. Leave that up to the lab technician. They're trained on how to do that. So from the field, we want to have that whole bucket, that whole sample, composite sample. Bulk specific gravity. The sample must reach compaction temperature before the test can be completed. The purpose of this test is to determine the specific gravity, the bulk specific gravity, and that includes air voids. So review the bulk specific gravity checklist in the procedures manual, and that can be different depending on your mix, if it's a Marshall mix versus a super paved mix. The TMD, the theoretical maximum density, otherwise known as the RICE or the GMM. The purpose of this test is to determine the specific gravity without air voids. That's what your theoretical maximum density is. The sample must be broken down to a 1/4 inch or less particle size. Again, review the TMB checklist in the procedures manual. Vacuum extraction. This is for checking the asphalt content. And then you can also do the gradation and crush content on that. Sample must achieve a constant mass and then cooled to an ambient temperature. Once the sample is cooled, record the weight of the sample and write it on Form 1839. There's forms for all of these testing protocols, and where you, I'm not going through all the details on all these test methods. That it's a week-long class to get certified in testing all this stuff, and we don't have enough time for that here today, but there are a lot of procedures. And ignition furnace, again, the purpose of this test is to determine the binder content, gradation, crush content. It's just a different way of doing it. I think typically, I guess I don't know. I know in some parts of the state, ignition furnaces are used, and in other parts, vacuum extractions are more typical for determination of asphalt content. I have this slide in here. It's basically a kind of shows you all the volume and weight measurements of a typical asphalt. And really, it's kind of a good chart. You can see which things are found on the JMF, your specific gravity of asphalt, specific gravity of aggregate, bulk specific gravity. And then you measure the GMM and GMB, and then you can calculate out your different volumetric properties, your percent air voids, percent VMA, and VFA, voids filled with asphalt. So that's kind of my quick presentation of testing methods. Are there any questions on that?
Yeah, we do have one more question about the non-nuclear gauge. Do you know if MDOT has any guidance or a manual document, anything like that, for use of those gauges on local agency projects?
I know they have a whole training class on density, and there's a certification for that. I would imagine it'd be in there. I'm not totally familiar with that.
Yeah,
I think since there are two different ways of measuring density in the local agency specification, I think if one option is a nuclear gauge, I think you can only use the non-nuclear if you're using the number of roller methods with the gauge.
okay.
Because then basically what you're doing is you're after each roll, you're taking a shot, and then you want to see that density curve, and then you back to one once it starts rolling over. So.
And just in my quick Google, it does look like there is a new density and testing inspection manual as of 2024 from MDOT for construction field
So
services.
it's probably in there, yeah.
Yeah.
Yep.
All right, I think, let's see, are there other questions here? Yes, we got a few folks who are answering some of these questions. All right, do we have anything else here? I think no. All right, so here's a question. Are the results from vacuum extraction and ignition fairly similar, or is one more accurate than the other?
What was that?
Are the results from vacuum extraction and ignition fairly similar, or is one of them more accurate than the other?
It really depends on your materials and your mix. I know that with the ignition furnace, you have to do a lot of pre-testing ahead of time to come up with your correction factor and that's very aggregate dependent. The vacuum extraction can be accurate. It's very highly dependent on the person running it, because you have to run it until you see a constant color coming out, and it has to be a constant weight and all. There's a lot of procedural things that go through that, and some of them are a little bit subjective.
Gotcha.
The problem with the ignition furnace can be if you're using certain aggregates, by heating it up that much, you're burning off the liquid asphalt, but you can also degrade the aggregates themselves. You can break apart, and then your gradation gets off. So there's not an easy answer for that, I guess. It really depends on your aggregates that you're using. And so that's why it's a very important thing to discuss at a pre-production meeting. To make sure that you know that, okay, yeah, we're good with doing a vacuum extraction, or we're good with doing the ignition furnace oven. I know from some of the contractors that in our association, some of them will not use the ignition furnace because of the aggregates that they're using for their mixes.
That makes sense.
So, yeah, a lot that goes into that.
Back to our non-nuclear method, it does look, I don't know that we have any local LAP MDOT folks in today's session, but it does look like maybe that is not currently allowed. Let me make a note, folks.
That might not be then. I mean,
let me make a note, and maybe I can get some clarification from those folks. Chuck, maybe I'll send an email, CC you. We'll see if we can get some clarification when we send out the certificates of attendance, the recording, all that stuff. If I have an answer by that time, I will include it. And otherwise, we'll be doing the session at the next week, Wednesday. The sport court session, and maybe we'll have an answer by that time. So let me make a note about this, and we will go with that.
Yeah, probably for acceptance, maybe it isn't. Maybe more of QC. I know our guys use the non-nuclear gauges all the time to figure out their rolling patterns and things like that. So I get a little confused with the number roller method part of the local agency spec. So that was put together years ago, and I'm not as familiar with that as I am the MDOT specification, I guess.
Well, and especially I know MDOT has put out new documents since 2020. There've been some updates to things, so it's possible that it was, and now it's not. We'll try and get you guys some clarification on that. I got another question. Are any labs still using centrifuge extractions?
I don't know of any, especially the acceptance labs. I don't think they are. I think it's all gone to vacuum extractions now. But you know, maybe certain labs maybe do a quick check with it or something. I don't really know, I guess. I haven't heard of any of those used in quite a while. I think I used to use them when I tested asphalt, but that's been 30 years ago.
Okay. Let's see. Do you need to run a bunch of density on cores, like via a water bath, to correlate results before acceptance? I'm thinking that might refer to the non-nuclear testing.
Well, that can be also for the nuclear.
Yeah.
As well. I mean, that is a best practice to do that if you can. You always want to correlate your nuclear gauge to an actual core if you can. Now the problem comes up where on certain jobs where they're not coring, how do you get that core to correlate it to? And so then you're really measuring more of a relative density based on your GMM of your JMF. So the different density values there, really. Yeah.
All right. Do we have any other questions?
Maybe we need to do a class on density.
Yeah, I think we might need to do a class that's specifically on density and all of the ways that you can test it and all of the pitfalls that you might run into as you're testing it. I know that was.
I do know, just working with Cray and stuff. I mean, one of the things that they want to look at is the density part of that specification. I mean, that was written back in mid 2000s, I think 2005 to 8 time frame, and it hasn't been revised since. So there's some people that would like to see some of that stuff revised, and that kind of goes to this whole, you know, part of my presentation here. The big part that I hope people take away from this is that, you know, sampling methods and testing methods are very important to make sure that we're all doing them the same, so that when we're comparing test results, we take out some of that variability and we're making the best decision possible that we can to accept these materials. So we all want materials. That's kind of where it all goes to. Yeah. So good.
Yes, for sure. I think especially, you know, on smaller projects, trying to get that variability can be a little bit more difficult because you're taking less samples, maybe overall. The more samples that you're taking, the easier it can be to test in a more varied way. But when you're only taking
statistics in your bell-shaped curve and your population of test results, and when your N goes up, your variability goes down as well. So yes. So on smaller jobs where you've only got 3 samples for that whole 1,000, 2,000 tons, that's not a lot.
Yes.
Typically, so, you know, when MDOT's running their statistical PWL spec, they're getting, you know, 10 samples there, and we might only have 3 on a local agency project.
Right. It reminds me, going back to the
risk.
the risk, and even just the
now we're talking about some of the issues
that pictures.
Yeah,
you know, the bullseye pictures. If you had only 3 dots, you're like, I don't know if that's good or not. If you have 10, it's a little easier to tell whether or not where you are in terms of accuracy and in terms of precision, for sure.
Yes.
Let's see. It doesn't look like we have any more questions, folks. If you have other questions on testing, please let us know. Let me put the survey link into the chat right now. So that's the SurveyMonkey link is in the chat. That's for the eval for today's session, as well as the the certificate of attendance for today's session, if you fill that out. The next session is going to be on Wednesday, the 7th, which is going to be about non-standard pavements. If you have somebody in your office or somebody else that you know of who would like to attend that, on our website, it says that the registration is closed. All you have to do is email ctt@mtu.edu. That's our main email address. If you email that and say, hey, I want to sign up for that asphalt class, we'll get you signed up. No worries. So I know that might be a little confusing. You're still able to sign up for that if you haven't. If you signed up for this class and you got a link for this class, you're automatically signed up for the next one. So hopefully that makes sense. I know it's a little confusing. Chuck, do you have anything else for folks?
I do have a slide at the end.
Okay.
About the next class too. So I got a few more slides here on identifying issues and kind of wrapping everything up, which we've already talked a little bit about, but
Perfect.
We'll go through that and go through any more questions that we got.
Perfect. Let's keep going.
Okay, so recall, quality assurance is a broad term that addresses all actions necessary to achieve project quality. QA is an umbrella term that includes quality control activities by the contractor, as well as acceptance activities by the owner. There are many parts of quality assurance. From this slide here, the examples of QC and acceptance tests, you can see there are many tests that are being run. Some of these are quality control tests and some of them are quality assurance tests. It's a great slide. I'm not going to go through it, but it's a great slide that shows you all of the stuff that's happening in order to, hopefully assure that we're getting a quality product. And it goes from the asphalt binder, starts out with the mix design and all that. And then it gets into testing the asphalt binder, the aggregates, the production, the placement, and even, measuring ride quality when we're done. All that stuff plays into having a quality asphalt product. So really, when we talk about statistically based acceptance plans, the components of that are acceptance sampling and testing, defining quality characteristics. What are we going to measure to assure that we're getting a quality pavement? What are our specification limits? When we're setting specification limits, we have to, account for this variability in sampling and testing and production and all that. So that all has to be taken into consideration. Hopefully we're using a statistical model because we're not testing every ounce of mix out there. What are our quality level goals? Where do we, is that, are those quality characteristics and our specification limits going to give us that quality that we want? We also have to look at risk and balance that risk between the owner and the contractor. If that risk isn't balanced, that can affect, how much you're paying. And then pay factors, you got to put that into there when you're putting together a specification. Some common challenges, really, you have to have a good understanding about the variability in setting the specification limits. If we set the specification limits so tight that we can't test that tight or we can't produce the mixture and meet those specifications, that's going to cause a lot of payment deductions or rework and things like that. And that understanding of risk, that's just going to ultimately end up costing you more in order to get that quality. So there's a lot of things that go into, setting all this stuff so that it properly works. Impact of small changes, like I talked about with sampling, if you're not properly getting that sample, then you're kind of skewing those results and everything else down the line. Test turnaround time, that can play a big role. It's really hard on these small jobs where we're getting them paved in a day, and we don't get test results for a week or 2 weeks later, sometimes months, I hear. So all that risk is being put on the contractor. So they got to rely on their QC results and things like that. So that brings up dispute resolution, and if you're not getting those acceptance results till later, but your QC results are showing that it's good, you got to have a dispute resolution process. It's important there if you have an outlier definition, if you can see that, well, that test result really is an outlier, or, when we do go down the path of a dispute resolution, make sure that we're using an independent laboratory to take out some of that, laboratory offsets or bias, or if there's any of that kind of stuff going on. So it's just important to have all that stuff defined, to make sure that we have a good quality system. And then offset between labs, like we talked about, that plays into just more variability. So these are some of the common challenges that I hear about, and really all the literature will talk about when you are, setting up a quality program for just about any construction materials. So with that, is there any other questions?
Yes, we do have a question specifically about an MDOT spec. Kind of a long one. So there's a perspective on asking about your perspective on one of the MDOT standard specs. It's 105.5, approval of materials incorporated into the work. So the spec reads as the engineer may inspect materials that the contractor will incorporate into the work at any time and at any place during the preparation, storage, and use of the materials. The engineer will perform inspections of the materials, including sampling and testing, to determine whether the material meets the contract requirements. So I'm not sure
what the question
is, but I guess what is your perspective on that spec?
I think you go into the standard spec section 100, and basically that's kind of a catch-all. The owner can test and sample at any time, because the way we set up our acceptance specifications, it's statistically based. We can't test every ounce of the mix and all that. Right. So statistically, we're trying to put together a spec that gives us a relative assurance that these test results are going to represent the whole. That language in there is put in there so that if you see a spot or see something that you think is suspect or something, you can take a sample of that and test it. And then you can't use that one sample there and say, well, it's all bad.
It represents, the whole thing.
Then you have to figure out, okay, what is that representing? And things like that. So I think that's what really that is there for. We hear that all the time from MDOT. Well, we can test and sample anything at any time. I know we've got our specification here, which is, generally how we're going to accept everything. But if we see something that we suspect is not right, then that we reserve the right to sample and test that at any time.
Yeah, the rest of the testing determination, that's a minimum. At a minimum, you're going to test however many, and then, like you say, if you see something that seems like it is deviating from the rest of the material, you have the right to also test that.
Yes. Yeah.
All right. It doesn't look like we have any other questions. Let me drop the survey into the chat one more time. If you've taken the survey and you're all set, then thank you for attending today. And Chuck, thank you for presenting today. If you have taken that Survey Monkey link, you're free to go. I'll hang out here for a little while. Again, if you've signed up for this class, you're also signed up for next Wednesday's Lunch and Learn, which is about non-standard asphalt, sport courts, trails, and more.
And more.
Let's
see what those are.
Yeah, exactly. I know we have quite a few of you who are doing designs on things like, I know my local town just put in a pickleball court. So things like that, the trail pavements and whatnot, we're going to talk a little bit about those next week. So again, thank you guys all for attending. You're free to go if you've grabbed that SurveyMonkey link. Please grab that before each attendee will get a certificate of attendance. You're not going to get it immediately after you fill out the survey. It takes a little bit of processing time on our side to get that done. So it might be a week, it might be a little bit more. Like I said, we're a little have a little bit of a backlog on those, but we're working our way through them. So again, thanks everybody. If you have grabbed the SurveyMonkey link, have a wonderful rest of your afternoon. Hopefully we see you next week. We will be recording the session next week as well if you miss it. So I'm going to stop recording now.